Hello everyone. Let us together solve this beautiful square roots problem. We have the overall square root of 64 divided by 8 minus the square root of 63. I'm going to apply law of surds that says that when you have the square root of a over b, you can separate them into the square root of a divided by the square root of b. Meaning for this expression, I can write this as the square root of 64, then divided by the square root of 8 minus the square root of 63. With that said, we know that the square root of 64 is 8. That means we now have 8 divided by the square root of 8 minus square root of 63. So the main problem we need to first tackle in this expression will be the denominator here. I'll bring that out as square root of 8 minus square root of 63. Let us quickly solve for this. Then when we get the values, then we come back and divide 8 by whatever we get from here. So we are dealing with the square root of 8 minus the square root of 63. What I'm going to do here is similar to something I've done in a previous video. Kindly watch the video that pops up. I'm going to equate this to, let's pick two random variables. I could have said a, because this is negative here, I can say a minus b. But I'm going to use the square root of a minus b. For better understanding on why I've chosen a or b, square root of a or square root of b, kindly watch the video as I've recommended. So it means that the square root of 8 minus the square root of 63 is going to give us the square root of a minus the square root of b. If I go ahead and find the square of both sides, let's square both sides. This takes care of this. And on the left hand side, I have 8 minus root 63. Then on the right hand side, if I expand this, I have the square root of a squared minus 2 root a root b, then plus the square root of b squared. Of course, this takes care of this, and this takes care of this, so that the new equation becomes 8 minus the square root of 63 is equal to a minus 2 roots. I can put this together by law of surds, 2 root a times b, then plus b. I'm going to collect like terms. Let's say this is 8 minus the square root of 63 is equal to this a, then plus this b. I have a plus b, then minus 2 root ab. From here, we can apply equality of surds. By equality of surds, a plus b is equal to 8. Because the signs are the same, minus minus, then 2 root ab is going to be equal to root 63. I'll put that out and say a plus b is equal to 8. And then I'll say 2 root ab is equal to root 63. Let's call this equation 1 and call this equation 2. In equation 2, I can square both sides. And when I do that, by simple indices, this will be 2 squared times the square root of AB squared. And then on the right hand side, this takes care of this. I have 63. This will give us 4. This also takes care of this. And then we have AB is equal to 63. Let's call this equation 3. I'm going to write equation 1 and equation 2 beside each other, so we have a clear picture of what we are dealing with. The first one is A plus B is equal to 8. And the second one is 4AB is equal to 63. Just to confirm, A plus B is 8. And then 4AB is 63. That checks out. So we have two simultaneous equations and we want to solve for A and B. From the first one here, I can make B the subject of the formula, giving us 8 minus A for the value of B, and then I can come here and substitute A minus 8 minus A into second equation. That gives me 4A into 8 minus A is equal to 63. If I open up this bracket, I have 32A minus 4A squared is equal to 63. I'm going to rearrange in descending power of A. This will be negative 4A squared plus 32A, then minus 63 is equal to 0. Let us multiply through by negative 1, so that this gives us 4A squared minus 32A, then plus 63 is equal to 0. We now need to check to see if this equation is factorizable. We first multiply 4 and 63. So 63 times 4, this is 12, and this is 252. So what do we multiply together to give us 252, such that when added together will give us 32? What I always do in this case is quickly do a long division. I have 252, then I can start with 2. This is 1, 2, 6. 2 again, this is 6, 3. I have 3, this is 21. 3 again, and this is 7. So I have 2 times 2 times 3 times 3 times 7. So listing out the factors like this will help me see easily if this is still factorizable, because now I can say 2 times 3, which is 6, then times 3, that's 18. And then what's left is 2 and 7, which is 14. So times 14 is actually 252. And then if you add them together, it also gives you 32. So I need negative 18 and negative 14 to replace negative 32. So this becomes 4A squared minus 18A minus 14A plus 63 is equal to 0. Let us factorize. 2A into 2A minus, this will be 9, then minus 7 is common here, and I'm left with 2A minus 9 is equal to 0, meaning that 2A minus 9, then 2A minus 7 is equal to 0. Therefore, 2A minus 9, either 2A minus 9 is 0, or 2A minus 7 is equal to 0. From the first one, A will give us 9 over 2. And for the second one, A will give us 7 over 2. And remember the value of B when we solved for b earlier, we got 8 minus a. Let's confirm that. Here, b is 8 minus a. So we have 8 minus, for the first a, let's call this b1. Then we have 9 over 2. That means b1 is equal to 16 minus 9 over 2, which will give us 7 over 2. And for the second one, b2 is going to be, so this is a1, this is a2. This would be 8 minus 7 over 2. So b2 is equal to 16 minus 7 over 2. So b2 is equal to 9 over 2. So since the square root of 63 is smaller than 8, because square root of 64 is actually 8. So square root of 63 is definitely smaller than 8. Therefore, a has to be the bigger one. So our solution now will be the square root of 8 minus the square root of root 63 is equal to the square root of 9 over 2 minus the square root of 7 over 2. By surds, we already know that this will be square root of 9 over square root of 2, then minus square root of 7 over square root of 2. Because the denominator is the same, we can express this as square root of 9 minus square root of 7, then divided by root 2. Of course, the square root of 9 here is 3. So that means that this is equal to 3 minus the square root of 7 divided by root 2. So remember where we are coming from. This is just the denominator. And we got square root of 64 for the numerator, which we did here. Square root of 64 is 8. So we now have to divide 8. All of this denominator now is what we just got. So we are now going to say 8 divided by all of what we just got. Let's go back to the solution. Is equal to 8 divided by 3 minus root 7 divided by root 2, which is the same thing as saying 8 divided by 3 minus root 7 over root 2. If we change this division sign to multiplication, that is now 8 times, you have to swap the fraction. So you have root 2 over 3 minus root 7. And if I write that together, this becomes 8 root 2 divided by 3 minus root 7. This is supposed to be our final answer, but of course, this is surds, and you cannot leave a surdic expression at the denominator here. So you need to multiply by the conjugate of the denominator, which is simply 3 plus the square root of 7. And how do you multiply that? This is how you are going to do it. We have 8 root 2 divided by 3 minus root 7. So you multiply both the numerator and the denominator by the conjugate of that denominator. And 8 times 3, that gives us 24 root 2. Then plus 8 root 2 times root 7, that will be 8 root 14. Then divided by, since this will give us difference of 2 squares, this will be 3 squared minus root 7 squared. So this will give us 24 root 2 plus 8 root 14, then divided by, this is 9 minus, this cancels this, so you have 7, and then we have 24 root 2 plus 8 root 14, then divided by 2. So let's separate this fraction. This is equal to 24 root 2 over 2 plus 8 root 14 over 2. This is 12 here, and this is 4 here. So we have 12 root 2 plus 4 root 14. Now remember what the problem is. We were given 64 divided by 8 minus root 63. So this is our final answer for this problem. Thank you so much for watching. If you have enjoyed this video, kindly hit that like button, subscribe to my channel, and I'll see you in my next video.